And after that, you'll remember we'll be giving away a couple more door prizes right after Mark's presentation.
Let's see. Clicker. Am I on? Okay, I think so. All right, well, as you mentioned, I have the unenviable position of being last of the day, but hopefully you'll bear with me. Some of you have probably seen this before. We've been talking about NOS3 for a couple of years. Maybe it'll spark some new ideas, though, and new questions, and for others, it will be new. So I'm going to talk about the NASA Operational Simulator for Small Satellites. In doing that, this is my agenda. I'm going to talk a little bit about our team and what we do, which kind of actually naturally lent itself to the development of NOS3 and a small sat or a CubeSat called STF-1 and how that played into NOS3. And then I'm going to talk about a couple of things, how we used NOS3 for doing day in the life, on-orbit operations, and ground station testing. And then another outshoot of it that happened this late, is finishing up this year, is how NOS3 then was used as a framework to demonstrate some spacecraft security. And then at the end, a few years ago, John Lucas put together a video, and so I'm going to show the 2 minutes of NOS3 and describe it to you so you can actually see it as it works. So a little bit of background about the group that I work for. So I work at the NASA IVNV facility in Fairmont for the JSTAR Independent Test Capability Team. And what our mission as a team is to acquire, develop, and manage adaptable test environments so that the IVNV analysts at the facility then can actually do dynamic analysis on the software behaviors for quite a few large NASA missions. And so I've got just two examples of simulators that we worked on. As I said, we don't necessarily develop them from the ground up. We take what's already there, we figure out what needs to be put in to make things software-only simulation, and so on. So the one on the left is for SLS, and the one on the right was one we had worked on for James Webb called GIST. So then what was NOS3? So NOS3 was then our attempt to do the same sort of thing for CubeSats. So what we did was we brought into a single virtual machine. We were developing our flight software on top of CFS, which we talked about a lot today. We were using the Ball Aerospace Cosmos ground station, so we brought that in. And then what we wanted to do was stand up a number of hardware simulators in software, and so we needed a couple of things. We needed a dynamics engine to actually provide some of the data for position and attitude of the spacecraft, position of the planets, that sort of thing. So that's where we brought in 42, which is developed at Goddard Space Flight Center, and it's also being used for visualization within NOS3. And then the other piece was we needed to have software instances of communication protocols like I2C and SPI, and so we used our NOS engine infrastructure in order to do that. And what we did then was we joined it all into one virtual machine so that you could have an entire software simulation of your CubeSat stack in your ground station. As I said, we then ended up using it for quite a few different purposes early on often, and we didn't have hardware. So we wanted to get started actually developing flight software, but without hardware. Sometimes that's rather difficult to do, so we used it for doing some of that work. As we moved along in our development of our CubeSat, we needed to do various integration tests, and some of it we would want software simulators in there, some of it we would want actual hardware, and so we would use it for integration. As we're planning out our missions and how we're actually going to conduct everything, we would use it for that. And then, of course, to verify and validate that we're actually going to meet our requirements on orbit, we used it for that as well. And I have down here then a list of components that we actually created hardware simulators for within the NOS3 infrastructure. So Blue Canyon's exact ADCS system. We created one for the Cadet UHF radio, some for the batteries that we're using, and then some generic science instruments. So we wanted kind of some sample example apps for people to get started with, or example hardware simulators that you could write an app to get started with. And then we're using the ISIS space antenna, and then the Novatel GPS. So we build up or hardware simulators for all those. So how does this play into STF-1? Well, I think you've kind of probably figured out by now. I keep talking about our CubeSat. So what we did was we proposed a mission for a CubeSat called Simulation to Flight 1. It's the first one built entirely within West Virginia, and we're manifested. Actually, we're supposed to launch very soon, from my understanding. So hopefully yet this year. So the objectives then, the primary objective of this CubeSat was to develop the whole infrastructure around it, the open source simulation, software simulation, so that it would make it easier for us and for others then to use this tool set for their own development. In addition, we actually worked with West Virginia University, and there are some meaningful science payloads on board. We have 2 from the Physics and Astronomy Department, 2 from the Mechanical and Aerospace Engineering Department, and 1 from the CSEE Department. So those are other objectives we had. And then, as most missions have, we have outreach type objectives where we're trying to get more involvement with the public and kind of build up then the STEM workforce and all those kinds of things that I think all of us are probably doing on missions. So in terms of day in the life, so we would want to do things like, see if the software is actually behaving according to the way it's supposed to. So what we have in the bottom right is we have an antenna simulator, and so after deployment we have to be passive for a certain amount of time. Then we're allowed to start deploying, powering on, deploying antennas, and so on. So we have a simulator to drive that, and then we can watch the flight software as it goes through those steps to make sure that it's actually following those requirements. We can use it for other purposes, training for the mission, verifying that this sort of ConOps is actually going to work. What happens if the antenna doesn't deploy the first time? Look into failure types of scenarios and how our ConOps would play out with that, and so on. So day in the life type testing was some of the things that we used NOS3 for. On orbit operations. So we have states where what we did was simulate of course, we're power and data and communication limited like most missions are. So if we don't have enough space in the radio to conduct an experiment, what happens in that case? So that's what's going on in this type of scenario that's shown on the right here. It says, okay, the radio sim has determined that the queues of all, or the FIFOs have all filled up. If what happens in this case, so in this case you can see then that the flight software says, okay, I can't run right now. I have to wait until those resources become active. And then we could also do other types of testing for failures of various components. So we could have a component go away and then verify that the software is actually going to appropriately respond and not just lock up or something like that. Ground station testing. So, of course, like everybody else, we have to build up our database of telemetry and command tables, and we have to verify those. So we could do that as we were going along. So we started out with just within the CFS environment, the TO lab and CI lab to do telemetry, output, and command ingest to start our tables, but then we actually wanted to know that the data was going to flow the whole way through the radio correctly too. So at the next step, when we had an actual cadet radio simulation to show that all the data flow through commanding and the telemetry going back into the buffers in the radio and coming to ground all happened appropriately. So those are some of the other kinds of tests we did. So we're building up more of an end-to-end testing suite all within software. Of course, this doesn't alleviate the hardware testing that we ended up doing after that as well, but it helps to get you further along in that path and provide things like having multiple people be able to run the software simulations and do that kind of testing, which you wouldn't necessarily be able to do since we have a single string of hardware. As I alluded to at the end, and those were some of the things that we used it for STF1, but then NOS Cubed was later used for another study into incorporating security in some of the CCSDS protocols and to show how a cryptography library could actually be incorporated within that. And so we could demonstrate AES encryption on the downlink within that whole framework. So again, this was done entirely within the simulator without having the need for hardware, but it provided a really nice platform of starting point to do this kind of development and work, and demonstrated in the end that this type of work doesn't have to be expensive or time consuming. We can do it within this virtual machine environment to get started with. And so demonstrate some more value from a system like NOS Cubed. So I think at this point, the last thing was, as I said, this is like going to be the wrap-up 2 minutes of NOS Cubed, watching the windows, and I'll describe what's going on. So as I said, it's a virtual machine. I'm going to actually go into full screen mode. So we actually have created some nice sample packages. Everything has commands to start things up. So we have a simple start script to start all the pieces up. What we have going on, and it's going to go through this, we have our flight software starting up here. We have 42 in the background that's going to provide dynamics data to things like our GPS simulator and for attitude and magnetic field data. So that's what's being shown in this window. This is our NOS engine portion that's providing the communication buses, such as I2C and SPI buses. See, down in this part, we have our Cosmos commanded telemetry, so we're going to do some connecting to the TO lab. And we see we actually have telemetry packets flowing from the flight software down into Cosmos. We'll show some commanding within Cosmos, the ability to do that, and we can see actually within the flight software we receive that command. And then last, some of the various hardware simulators that are running and providing data on the simulated hardware buses that end up flowing to the flight software. We're showing example of other commands that we can send. And as I said, it's actually flowing the whole way through the system from end to end, and the dynamics as well interacting with all the simulators. So at the end, it shows, okay, we actually have some data that's due to the commands and due to the processing on the flight software computer. This is the type of telemetry that's being produced. So I think that's pretty much the end of it. Right. Yeah, so there's that telemetry. And then again, we have some nice convenient scripts that allow you to shut everything down. Let's see, so with that, come back to and so I think we're at the end. So the last thing, it is actually open source now. If you go to www.nos3.org, you are able to actually pull down, it has a link over to the GitHub site. You can pull down, create the virtual machine, and have an instance running like we had and showed here. So I think with that, any questions?
I'm curious about the development of these hardware simulators.
Okay.
So did you mainly work off the ICDs for determining what behavior to simulate, or were you also working with the actual hardware too?
A lot of them we did actually with just the ICDs. Like, for example, I worked specifically on the Novotel one, and I worked in depth with the ICD there. So I wasn't working with the hardware. I mean, of course, then, you know, you want to verify it against the actual hardware, which we went and did some of that then. But no, we actually, in some cases at least, went straight from the documentation provided by the vendor.
Did you do much reconciliation once you started testing with the actual hardware? Like, did you go back and revise your models in the simulators?
That, unfortunately, that's a good question. I was involved in a portion of the project, but I'm not the lead developer for it, so I think he would have seen more of that. I know some of them changed some, but I can't give you a real detailed answer on that. Obviously, we didn't get it all right the first time.
Just an acronym. Is there any relation between this and NS3, the network simulator?
No.
Or is it just a curious acronym
I think it's,
coincidence? Because that's a network simulator.
NS3, no.
I don't know why there's 3 on that one. Okay.
No.
Random coincidence.
Yep.
Any other questions? Okay. All right. Thank you, Mark.
Yep.